Hi everyone. We are looking at question number 4 on midpoints and perpendicular bisectors of line segments. Question number 4 says, find the perpendicular bisector of the line segments joining the pairs of points. These two questions here we have. The first one, we have a minus 5,8 and b 7,2. Then we have the second one, x 13,11 and y 5,11. Let's look at the first one first. Now here we are going to try to find the perpendicular bisector of a line segment that is joining 2 points. So let's look at this first one. It says minus 5,8. Let's try to put a diagram that might help. Minus 5,8, x is minus 5, y is 8. So let's say minus 5,8. Let's say that is the point. And b is 7,2, 7,2. This is 7x, and y is 2. So we join these 2 points like this. One point is there, one point is here. This point here is minus 5,8. So this is 8. Here is 5. So this is 7. Here is 2. What the difference? It doesn't. Let's slant it a bit. It's 2. Got to be something like this. Correct. So now know this is 5 and there is 7,2. Correct. So we have here, this is our A here, minus 5,8, and this is B, 7,2. Just to give a brief, y and x. Right? Let me take out this manual here. So that is the point. A minus 5,8 and b 7,2. We want to find the line that bisects this line segment, and that line should be perpendicular to this line segment. That is the most important. It's got to be perpendicular, and then it has to pass through the midpoint of this line segment, of these 2 points. It has to pass through the midpoint of these 2 segments, and at the same time it should be perpendicular. It should be at right angles to this line segment. So we are looking for that line. Now, first and foremost, let's find the perpendicular bisector of this. Any line that bisects this in the middle must have a midpoint equals to minus 5 plus 2, minus 5 plus 7 divided by 2, comma 8 plus 2 divided by 2. That will be the midpoint of this line. And any line that bisects it must pass through that midpoint. So the midpoint here, which is going to be, this is 2 over 2, 1, and this is 10 divided by 2 is 5. So that will be the coordinate of that midpoint. 1, 5. That would be the coordinates of the midpoints. So if that is the case, how do we find the equation of this perpendicular bisector? What we know already is that when two lines are perpendicular to each other, it means the product of the gradient of those two lines is equals to -1. When you multiply the gradient of those two lines, the product must be equal to -1. Now, can we find the gradient of this line segment AB? Yes, we can. Line segment AB, line AB, gradient call it M1, is equals to, you know what the gradient is? It's rise over the run. In other words, the increase on the y-axis divided by the increase on the x-axis. So the increase on the y-axis will take, this is our position B, so increase on the y will be 2 minus 8. No, it goes like this now. Got to be now 8 minus 2. That is the rise. It's going this way. 8 minus 2 all over the run. And the run is -5 minus 7. Yeah? The rise is 8 minus 2, and the run, the x-axis, is -5 minus 7. So this is what we have. So here we have -6. Sorry, yes, -6. Sorry, 8 minus 2 is 6. All over 5 minus 7 is -12, yeah? So this gives us -1/2. Yeah, that's why it slopes this way from left to right. So the gradient should be a negative sign. If it was this way, the gradient will expect the gradient to be positive. If the line is sloping from right to left, that gradient is positive. But if it is sloping down from left to right, the gradient is negative. Those are just things you can have at the back of your mind. In case the figure gives, you get the number something different from the diagram, then you know you are wrong somewhere if you have this in your mind. When the line slopes this way, gradient is negative. If it slopes that way, gradient is positive, always. Fine, so now we know the gradient of this line. How do we find the gradient of this line? That formula is very important. It's very handy. What did we say? The gradient M1, we say, is equals to the rise, which is y1 minus y. Let's say this is y2 minus y1 all over the run, which is x2 minus x1. This gives you the formula for the gradient. There are different formulas to find the gradient of a line, but it depends how the question is framed, then you know which formula to use. That will save you time. Because in this question, the way we are looking at it, this will save us time. This formula here. We already use it to find the gradient of this line. We know now the slope of this line is -1/2. Now, how do we find the slope of the line, this line here, 1,5, 1,5, somewhere, 1,5, somewhere here. So it's somewhere here. This position here, the midpoint of this line, is somewhere here, 1,5. and this is the one that bisects the line we are looking for. The line now we are looking for, we are now looking for the equation of this line that bisects. We are looking for the equation of this line P, because P bisects this line at the points 1, 5. We want to find the equation of this line, but we can't find the equation of this line without knowing its gradient. We'll now work out the gradient of the line AB to be minus 1/2. But what we know is that when two lines are perpendicular to each other, the product of their gradient is minus 1. So if this gradient, we say M1, and now want to claim that the gradient of P, gradient of the line segment P, line P, gradient, we say M2. We want to find M2. We don't know what M2 is. What is M2? We already stated M1 times M2 is equals to minus 1. The product of the gradients of the two lines that are perpendicular to each other is minus 1. So if 1 is minus 1, M1 is minus 1/2, times M2, we don't know what M2 is, and we know their product is equals to minus 1, which means M2, the minuses will cancel, yeah? So M2 is equals to 2. So the gradient of this perpendicular line to the line segment AB is 2. So now the question is asking us to find the equation, find the perpendicular bisector of the line segment joining these 2 points. So we are asked to find the equation of this line that bisects this line segment AB. Now we know its gradient. Since its gradient is 2, we know the formula for gradient already. The formula of gradient is the rise over the run. Increase on the y-axis divided by increase on the x-axis is equal to the gradient of a line. So if now the gradient of this one is 2, and we know that increase on its x-axis, y-axis, which is y, we say that minus y1 or y2 minus y1, this is 5, all over the rise, which is x minus x1. Yeah? Because this line passes through that point. So we can use this point with another point here. With another point here. All of this is P. With another point here, which we'll now label as y, x. Sorry, x, y. X, y. That's what we have done. Simply done. And we know now the gradient, we can choose any 2 points here. We know one, we can choose any other one, and then we form this equation. That's what we have just done. So the rise, which is y, minus 5, and the run, which is x, minus 1, must be equal to the gradient 2. So now, expand this. We have 2 into x minus 1 equals y minus 5. We want to put y on the other side there. So now you have y is equals to 2x minus 2 plus 5. Yeah? Is that correct? Yeah, 2x minus 2, so here. So now you have y is equals to 2x plus 3. This is the equation they ask you to find. That's the equation they ask you to find. Thank you for watching. Bye-bye.